Salam, good morning. My name is Fatma Garba Yusuf and this is Electronics. And today we are going to talk about corrosion. We're going to talk about different aspects of corrosion, its nature, the triggers that lead to corrosion, the types of corrosion, as well as the preventive measures that you can take against corrosion. So let's first start with a definition. So basically, corrosion is regarded as the degradation of or destruction of materials, especially metals or alloys of metals, due to chemical or electrochemical reactions with the surrounding medium or the environment. And this is mostly seen in moist areas, in areas of chemical activity, and so on and so forth. Now, most of us are actually more familiar with the term rust or rusting, and it's actually just a part of what corrosion actually is, because rusting is associated with ferrous or iron-based metals and alloys, while there are other metals that are non-ferrous, that is, they do not contain iron, but they actually corrode even though they do not rust. And then for a better understanding of corrosion, you'll need to revisit the topic electrochemistry, especially the aspects of the kinetics of oxidation. That's because in corrosion, it's a chemical reaction that occurs at the anode and the cathode. The seat of the corrosion is actually the anode, and when you revisit your electrochemistry, you understand it better. Next, we are going to look at the effects of corrosion. Of course, like I mentioned earlier, we are mostly familiar with the term of rust, and when a metal actually rusts, you will notice that it has orange, brown, or reddish deposits, just like you're seeing on this image here. This is like a metallic sheet that has corroded or that has rusted. So you'll notice some holes, the color will change, and so on and so forth. Another one is formation of holes or crevices. Because we are going to look at the different types of corrosion, there are actually different types. Some of them, in some types, you only notice deposits, and some you see holes or crevices where water has gathered, and so on and so forth. Then there's weight loss. This is because when a metal actually corrodes, because most of the time it involves eating away at part of the metal becomes lighter. Usually any type of material, if you punch holes in it, it will become lighter. So this will lead to loss of weight. Then of course, waste of natural resources, because if a metal corrodes, it becomes almost useless, whether it's in a refined format or any format. So this leads to a waste of natural resources. Then of course, there's reduction in luster and strength, and this is obvious because when a metal has corroded, its beauty diminishes. It's the shininess of the metal reduces a lot. And then the strength too, when you have a material and it has been eaten away by corrosion, typically it won't hold much, and the quality of course will decrease. Now just take a look at this. This shows some chains. On the left we have a corroded sample, and on the right we have a sample that hasn't corroded yet. So as you can see, this is quite shiny, while this is looking very unattractive. And typically when you try to maybe use this to hold a lot of things, maybe to tow a truck or something like that, the one that hasn't corroded will typically hold longer than the one that has corroded. Now next we are going to look at factors affecting corrosion. The first is exposure to moisture, especially brine, that's salt water. This really accelerates the rate of corrosion. Then the presence of impurities, likewise presence of acid in the atmosphere. Then temperature too also affects corrosion rates, and there's even a type of corrosion that's high temperature corrosion. The higher the temperature, the greater the tendency for the corrosion. Then also there's exposure to air containing gases like carbon dioxide, oxides of sulfur such as sulfur 4 oxide, and so on and so forth. And next we are going to look at the types of corrosion. Earlier, I've already mentioned that there are different types of corrosion, and they differ in terms of their nature, the materials affected, the triggers, the environment, and also the mechanisms. The first we have here is stress corrosion cracking. And stress corrosion cracking, as the name implies, it can also be actually abbreviated as SCC. As the name implies, it refers to the cracking of the metal as a result of the corrosive environment. So because the environment has the tendency to cause corrosion, it is called a corrosive environment. Then it results in a tensile stress on the metal, and it typically occurs at high temperatures. As example of a corrosive maybe solution or an environment is like chloride solution when you have steel introduced inside it. Next we have crevice corrosion. This one too, as the name implies, it occurs when there's actually a difference in ionic concentration between any two local areas of a metal. And this is actually a localized form of corrosion where an area is affected and another is not affected, and the area that is affected in a confined space, which is also known as a crevice. So for example, in bolt heads, that's the bolts we normally know, because it's a confined space, the type of corrosion that mostly occurs there is not surface corrosion but crevice corrosion. Next is oxidation corrosion, and this is actually the one that is most likened to rusting. Then there's intergranular corrosion. Intergranular corrosion, most of these corrosion types are actually self-explanatory because of their name. Intergranular corrosion, it occurs due to the presence of impurities in the grain boundaries that separate the grain formed during solidification of a metal alloy, or when the alloy gets depleted or enriched at any of these grain boundaries. Next, there's pitting corrosion. Now this is actually one of the most unpredictable types of corrosion, and it's very difficult to detect. Now because it's very difficult to detect, it's considered one of the most dangerous types of corrosion. Like crevice corrosion, it occurs at a local point and then proceeds to form a corrosion cell which is surrounded by the normal metallic surface. So it's a bit hollow, and that's why it's even called a pit. So if you don't take note of it much, you won't even know that something is going on until the pit slowly penetrates the metal from the surface in a vertical direction, forming a deep hole. Then if it's left unchecked, it leads to structural failure. Now something as simple as a droplet of water on a steel surface can actually lead to pitting if it's actually continuous. So at the center of the steel sample or something like that, the water will continue penetrating vertically downwards until perhaps it initiates structural failure due to the continuous pitting corrosion. Then we also have galvanic corrosion, and in this case there's electricity is involved. When there are some metals, maybe a couple of metals that are electrochemically dissimilar, but then they are in an electrolytic environment, then galvanic corrosion can arise. So when you have a joint of a couple of metals, and maybe for example when you have copper in a saltwater environment, then it comes into contact with steel, and saltwater environment is actually an electrolytic it has electrolytic properties. So when they are connected and they are immersed in seawater, the corrosion is quite quicker than normal. As we mentioned earlier, some factors that affect corrosion are moisture and the presence of salts. So seawater is basically salt water, so that's why the accelerated corrosion occurs. Then there's uniform corrosion, and it's actually one of the most common forms of corrosion, which is maybe depicted by the sample I showed earlier of a flat sheet of metal that is corroded on the surface. So an attack on the surface of the metal is executed by the atmosphere. So you will notice that sometimes, even if there's no direct form of pressure on a piece of metal, maybe on rooftops, because it's exposed to the atmosphere, then corrosion attacks it and it changes the color. And because it's uniform, it doesn't form deep holes or something like that. It has relatively low impact on the performance of the material. An example is a piece of zinc and steel which is immersed in dilute sulfuric acid. So the corrosion rate here is constant. That is why it is called uniform corrosion. Next, we have microbial corrosion. So interestingly, corrosion is not only caused by chemicals or moisture, but also by microbes. And sometimes it is referred to as microbiologically influenced corrosion. That's MIC, and it is caused by microorganisms. Next, we have high temperature corrosion, which, as the name implies, it's a type of corrosion of materials that occurs due to heating, and materials in this case is obviously majorly metals. And deterioration of the metal can occur due to maybe a hot atmosphere that contains some gases such as sulfur oxides, oxygen, or other compounds. And these compounds, of course, are capable of oxidizing the materials. Remember, I mentioned that corrosion is related to oxidation. Next, we have metal dusting, and it's one of the damaging forms of corrosion that occurs when vulnerable materials are exposed to certain environments with high carbon activities, such as synthesis gas. So this results in actually breaking up of the metal to form a kind of dust, which is why it is called metal dusting. So here I am going to stop here and show you some images of some types of corrosion. Like I mentioned, pitting corrosion forms a vertical downwards hole, while crevice corrosion occurs in localized areas. Then we have grain boundary corrosion, where we have alloys that are fused together, but then there are some grain boundaries, so the corrosion occurs at those grain boundaries. Then there's stress cracking corrosion, and this of course occurs due to stress, especially tensile stress. I'm going to pause the video here, and in the next video I'm going to talk about prevention of corrosion, and then we're going to go over some formulae that I used in calculating corrosion values such as weight loss, corrosion rate, and so on and so forth. Thank you very much.